Hello, welcome to this walkthrough of the Year 10 Set 1 Linear Graphs Assessment. I'm just going to go through the question one by one and show you how you could do these. So number one, we have x plus 2y equals 8, and we just have to plot it. So let's make x and y, let's just make some coordinates. X is 0, if x is 0, then 2y equals 8, so y has to be 4. Well, what about if y is 0? Well, if that's 0, x will have to be 8, because 8 add 0 is 8. You can do it with just two coordinates, but it's often nice to check to make sure you're on the right line. So, well, what if x is 2? 2 add 2y is 8. Y would have to be 3. 2 plus 2 lots of 3, 2 plus 6 is 8. You would then plot these points. So 0, 4, 8, 0. Just check 2, 3. Sorry, yep, 2, 3. And make sure you do a nice line. You really should do this in pencil. I know I'm doing it in pen here. Setting a bad example, but there you go. Now, that was question one. So it's just plotting the graph. Question two, the point 0, 1, 0, negative 1, which is there, and 4, 5 lie on the straight line now. What's the gradient? So remember, the gradient is difference in y over difference in x. So let's do this. So we've got the 2 points 0, negative 1 and 4, 5. So the difference in y is 5. Take away negative 1. Be very careful with negatives. Over 4 minus 0. So what do we get? We get 5 take away negative 1 is 5 add 1. 6 over 4. If you want to do that as a decimal, it's 1.5 or 3 over 2. Up to you, really. Now question 3. Can we see that? Good. So here we are. We've got 3, 7 to 7, 14. We need the midpoint. Well, what's halfway? The x midpoint, halfway between 3 and 7. So one way to do this is do 3 add 7 and then half it, take the average of them. 10 over 2, which is 5. So the x midpoint is 5. Sorry, you didn't quite see that probably, but that's how we do it. And then the y midpoint, you've got the 2 points, 7 add 14. So 7 add 14 over 2, 21 over 2, 10.5 if you want to do a decimal. So 5, 10.5 there. So that's not very tidy. Right, let's have a look at this one. Line A has equation 3x minus 4y equals 5. And line B goes through the points 4, 7 and negative 1, 3. Show that these are parallel. Well, there's the little twist. We'll find they're not parallel. So that did cause some confusion. Let's look at A. So if I rearrange A, I've got 3x minus 4y equals 5. I'm going to move the 5 across and, well, I'm subtracting 5 from both sides. I'm adding 4y and then divide everything by 4. You've got y equals 3 over 4 x minus 5 over 4. So the important thing is, for A, the gradient equals 3/4. Now let's have a think about B, line B. For line B, what's the gradient? I'm just going to call it M. So I look at my 2 points, 3, I've got 3 and 7. Well, let's do that one, take away that one. We're dealing with, I'll write them out there so you can see, 4, 7. And we've got negative 1, 3. You can do either, take away the other. I'm going to do this, take away that one. 7 minus 3. As long as you do the difference in y over the difference in x, 4, take away negative 1. So you've got, at the top, you've got 4 over 5. Well, look at those two gradients. The gradients of A and B are not equal, and therefore I'm running out of room here a bit. A and B are not parallel. So that one, we find the gradients of the two lines. This one, A, using the equation, put it in y equals mx plus c form. And this one here, difference in y over difference in x. Right, so let's have a look at the next one. That was the first page. This is the second one. What's the, find the equation of the line perpendicular to AB passing through B? Well, the gradient of, let's move this out a bit so you can see a bit more. Gradient of AB is going to be the difference in y over the difference in x. So 6 minus 1 over 10 minus 0. So that's 5 over 10, which is a half. So it's a gradient of a half. So this has a gradient of a half. I'm interested in the perpendicular line that passes through B. So I'm just going to draw it so you've got a bit of indication of what I'm going for. There you go. And I know that is going to have a gradient of negative 2. How do I know that? Well, the gradients of perpendicular lines are negative reciprocals. They would multiply together to make negative 1. So let's use the form y equals mx plus c, y equals negative 2x plus c, and I'm going to sub in 10, 6. So 6 equals negative 2 times 10. I'm subbing in my x and y coordinate there. 6 equals negative 20 plus c. C has got to be 26. So what is the equation? The equation is y equals negative 2x plus 26. Let's just review what we did there. Found the gradient of AB using the 2 points, 0, 1 and 10, 6. I found the negative reciprocal, so I've got the gradient of the perpendicular. I then sub in 10, 6 because it goes through B. Tells me in the question it goes through B. Right, so let's have a look at this next one. Oh, then of course we get the final answer. I'm rushing through this a little bit now. I don't want you to have too long a video. Let's just let that settle, see if it focuses. Right, the straight line. The straight line has equation 6 minus 2x. So just let me try and focus that a bit. 6 minus 2x, the straight line L2 is perpendicular to L1 and goes through 4, 7. So we know we are looking, that one has a gradient of negative 2. So L2 has m equals positive a half. So it's y equals a half x plus c. It goes through 4, 7. So 7 equals a half times 4 plus c. 7 equals 2 plus c. C equals 5. So you've got y equals a half x plus 5. So again, we know the gradient. So we know the point it goes through is y equals half x plus 5. That's not the final job though. So find the coordinates of the point where L2 crosses the x-axis. So crosses the x-axis, x-axis when y equals 0. So when y equals 0, So I put 0 equals a half x plus 5. 1 half x is going to equal negative 5, so x equals 10. So the coordinates, when it crosses the x-axis, my final answer here, negative 10. Negative 10, 0. The line will cross the x-axis at x equals negative 10, y equals 0. Just have a look at that. Find the equation and see where it crosses the x-axis when y equals 0. Right, this final question in the test. Point A has negative 2, 4. Point B has coordinates 8, 9. So D is a point with coordinates 100, 56. Show if point D lies on the straight line that passes through A and B. Well, let's find the equation of the line. The gradient of AB, call it MAB, is going to be 9 minus 4 over 8, take away negative 2, which is 5 over 10, which is a half. Okay, so we've got y equals a half x plus c. Let's put 8, 9 in to find the equation of the line. So we've got 9 equals a half times 8 plus c. So 9 equals 4 plus c, it's 5 again. So y equals a half x plus 5. So you've got the same equation as you had in the other question. Sure, that's by chance, but now let's see what happens if I put x equals 100. We're going to test the coordinate 156. So let's see what happens when x equals 100. Y is going to equal a half times 100 plus 5. So y equals 50 plus 5. Y equals 55, not 56. Therefore, D does not lie on the... D is not on the line that passes through A, B. There you go. Well, let's just have a quick recap. We did question 1, we plotted a graph, we got some coordinates. That was working out the gradient, just a reminder of that. Question 3 was about midpoints. Testing whether gradients are the same. If gradients are the same, they are parallel. Here we found the gradient by putting it in the form y equals mx plus c. Here we found difference in y over difference in x. Question 5. We were finding the equation of the perpendicular. So we find the gradient of that line, we take the negative reciprocal, and we use our y equals mx plus c method. We know m is minus 2, and we substitute in 6 and 10. X is 10, y is 6. This one we're finding an equation again, using the method we're now hopefully familiar with. But the key one thing is, crosses the x-axis when y equals 0. Okay? Crosses the x-axis when y equals 0. So we put y is 0, and we solve that to get x is negative 10. The last one, again, we're finding an equation of a straight line, and we're testing whether 156 is on there. Well, I put x is 100 and I get 55, so it's not on there. And I've got sufficient evidence to show that. Okay, I hope that's clear. Thank you.